Hey everybody, this is a video to show you how you can use Excel to do linear regression and also to do some of the other fun-filled things that you actually have to do for experiment 2. Okay, so here is my spreadsheet and here is my table of calculations. As you can see, it's pretty empty. And what I'm going to do is I already have my distances here, and over on the header here, I'm going to put in my time. So that's just going to be T1, T2, T3, T4, T5. And I also am going to need to find the average time. See, average, okay. Standard deviation, that's what that is. So I'm just going to type in STD DEV. Absolute error, I'm just going to call that ABSERR. And then for this one, I'm just going to call that time squared, or T hat 2. Plus the hat there is the universal thing for the universal sign for raising something to the power. And I have a whole bunch of data. You can't see it because I have it hidden on another screen. The data that I have here is not experimental data, it's kind of contrived data. Essentially, it's the actual calculations with a bit of randomness, with a bit of randomness thrown in there. So my results are going to look a lot better than yours. But let's just go ahead. But we're just trying to do the process. Let's just go ahead and work with these. So for 0.25 meters, I have 0.74, and I can hit tab to go to the next one. 0.74, 0.73, 0.75, and 0.72. Okay, you can come down to 0.5, and that is 1.05, 1.03, 1.05, 1.05, and 1.02. And I'm just using the tab button to go between to advance the slides, and then the cursor buttons to head on back. Now for 0.75, I have 1.28, 1.30, 1.26, 1.26, 1.27. And then finally, for this one, 1 meter, I have 1.45, 1.48. Oh, let's try that again. 1.48, 1.49, 1.49, 1.47. Okay, so that's all the data I have in here. And I also have down here my height and my width. They're in meters. But let's come back over here and work on our averages here. So now for average, what you can do is type in equals sign AVE. And right there, that's average. That's what we want. So we can click on that, or you can highlight that, and then hit tab. Don't hit enter. Hit tab, not caps lock. Oh, that was wrong too. Let's try that one more time. AVE. No. AVE equals AVE. Let me just hit tab. That's what we want. You just hit tab. It brings you to that. And then you can highlight these numbers. You can use your mouse or you can use a keyboard. It's up to you. For this one, I'm going to use my mouse. There they are. Okay, I'm going to close the parenthesis and I'm going to hit enter. Okay, and now that I have that for this particular value, what I can do is I can copy this, and what it's going to do is and then I can paste this formula into the other two rows, and they will increment accordingly. So there we go. We're done. We actually have that. The other thing that we need to find out is and we can take these values and put them into here, and really the best way might be once you have them just to go ahead and type them in. So that would be 0.763, 36, my bad, 1.04, 1.274, 1.4, 6. Okay. Next, we need our standard deviation. We need a standard deviation so we can actually compute the absolute error. And your standard deviation, to do that, we are going to type, we can say equals STDEV, and that's what we want. This is what we call the population standard deviation. You can hit tab, okay? And then using my cursor, I can move to T5, the one under T5, hit shift, and then go all the way down to T1. Once I've done that, close my parenthesis. There it is. And there's my standard deviation. Then, once again, I can copy that and then paste that formula, because when you're pasting stuff in Excel, they are formulas, unless you tell it otherwise, and then hit enter, and that formula is copied with everything incremented. Now, the next thing that we have is the absolute error. Okay, and the absolute error, here it is right there, alpha sub t, since it's basically the absolute error in time, that is going to be the standard deviation divided by the square root of the number of samples. In that case, it happens to be 5. So it's going to be the standard deviation, the thing we just computed, divided by the square root of 5. Okay, and guess what? Guess how we can do that? We can highlight this cell right here, hit equals, highlight that cell right there, square root or standard deviation, divided by SQRT for square root, and then parenthesis 5 parenthesis. There you go. And oh, I forgot one thing, kind of important. It's actually the absolute value divided by the square root of samples times 100%. So this should be times 100%. So let me just clean this up a little bit because that looks pretty bad. Thank you. Let me try that one more time. Okay, so the standard error in seconds is going to be the standard deviation divided by the square root of the number of samples times 100%. Okay, which in our case is going to be sigma divided by the square root of 5 times 100%. Okay, so let's come back to this formula right here. And let's just do it one more time. Equals that value right there divided by SQRT 5 parenthesis 5 times 100. There you go. Okay, now we can copy that. And we can put these values here, or we can paste, and those are our absolute errors. And of course, we can fill out that information here. Then the next thing that we need to do is compute this time. It is compute t squared. And why do we want to do that? Well, keep in mind that my displacement x is going to be equal to some number, the slope, times t squared. So if we have this value, and so there's a linear relationship between the square of time and x, and we want to find the slope because it turns out that slope is going to be 2 times acceleration. How do I know that? Well, because x is equal to 1/2 a t squared. So if we plot a against t, if we plot x against t squared, we're going to have a linear relationship. And yes, this will be the slope. So if that's the case, this should be m. Sorry about that. If that's the case, then a is going to be equal to twice that slope, which is kind of indicated there. Okay, so we need to figure out what t squared is. So the way we can do that is equal sign. Notice here's the average time. Hit caret because that's the universal sign for the power, for raising something into a power. 2, that's t squared. That's t squared. Once again, we can copy, and then we can paste it into the other 3 lines. Okay, now another thing that you're going to, so, and with that in mind, we can actually then do our linear regression. Okay, now the way we're going to do that is to use the function, actually let me do it down here. We're going to use the function equals LINEST. Okay, that's basically the linear regression function. I guess you call it linest. And we're going to hit parenthesis. And notice what it wants first is the known y's. Well, the known y's are going to be the x. This is y, t squared is x. So we're going to put the distances in for the known y's. So we can just do that like I just did over here, just by highlighting those 4 cells. Hit comma, and now it's ready for the known x's, which will be t squared right here. Okay, there's a few other things that we can do, but this is really all we need to do. Close the parenthesis, hit enter. Okay, this right here is the slope, and this right here is the y-intercept. Remember, your linear equation slope-intercept form is going to be y is equal to m. Well, in this case, I'm going to use t squared plus b. Okay, that's the y-intercept. That's where the line crosses the y-axis, and this is our slope. So this is our slope right here. Okay, and that will be 0.4. It's supposed to be a 4, by the way. 4, 5, 8, 5, which would round to 0.459. Okay, your acceleration, I call that A, is going to be equal to that number times 2. Okay, and that's what will go here. That will be 0.917. 0.917. Now, to compute your acceleration due to gravity, we are going to need to use a version of this equation right here. Here we have A is equal to g sine theta. So g is going to be equal to A divided by sine theta. Okay, what is sine theta? Well, here's theta. So sine theta is going to be the height that we measured before, h, divided by the length of the hypotenuse here, which we didn't measure, but we did measure the width, and we could compute the hypotenuse using the Pythagorean theorem, h squared, square root of h squared plus w squared. Okay, now here I have my h, and here I have my w. So the sum of the squares I can compute by going equals h hat 2, okay, that's h squared, plus w, oh, I didn't want to do that, hat squared, okay, so that's my hypotenuse squared, okay, take the square root of that number over there, that is my hypotenuse, and then sine of theta is going to be equal to h, that's h right there, divided by my hypotenuse, which is that number right there. Okay, so that is sine of theta. And therefore, g, acceleration due to gravity, is going to be equal to the value I got for A right there, divided by my value for sine theta, which is right down here, there, okay? And there it is. In that case, I got 9.97 meters per second squared. I can come down here, and I can put that information in here. Oh, I already have the units from there. Now, what is my error? My error is going to be essentially the value g that I got minus the correct value of g, okay? And we just want the magnitude. We don't care about the sign. Divided by the correct value g times 100. Okay, so I can do that as well. In that particular case, I think I typed in my acceleration due to gravity wrong. That should be 9.79. Three significant digits is fine. 9.79. Okay. So we're going to use a G of 9.81 for that. So we'll just keep that in mind that for us, G is equal to 9.81. Okay. So my percent error, and you don't have to do these on the spreadsheets. You can actually just do that on your calculator, but now since you're here, you can. So that's going to be parenthesis, that value. Let's do it like this. My error is going to be equal to the absolute value of that value right there minus 9.81 close parenthesis divided by 9.81 times 100. And that is my percent error. My percent error here is 1.868, which rounds to 1.87. Or 0.187. Okay. And then finally, we need to do R, which is our correlation. The correlation is a measure of how linear the relationship is between two data sets. So if it is, if the correlation coefficient happens to be 1, it is linear with a positive slope. If it happens to be -1, it is linear with a negative slope. If it happens to be 0, that means that there's no linear relationship whatsoever. But over here, so what I'm going to do is I'm going to type in R here, and the function that we can use to do that is CORREL, Correl, okay? And we want to find the correlation between time squared and then distance. Okay. Now it doesn't matter in this particular case. It doesn't matter which comes first. You can do distance then time squared or time squared then distance, and that is our correlation coefficient. Our correlation coefficient is basically 0.999977. Okay, which if you rounded it will be 1, but I'm going to write that down as just simply 0.9997 and just leave it at that. All right. So that is how we can get all of our information. Now we need to talk about how, well, you already see it there, but we're going to do it again, I think. Wait, maybe we need to hit it out here. There we go. How we can actually do our graphs. Okay. Now the first one is a displacement versus time graph. So here is displacement and here is time. Now, the way that we want to do that, the best way to possibly do this, or the easiest way, is to take your time values over here. I'm going to put down a header for time. That's not time. Time, and then displacement. Okay. So I'm going to take my time values here, and I'm going to copy them. I'm going to come down to here. I'm going to do a right click. And this is what I want right here. The paste with the 1, 2, 3, that just pastes the values. Okay. And that's kind of important because if I just did a straight copy and paste, they paste formulas. And we don't want the formulas. We just want the values. Okay. To do that one more time. So that was time. Then for distance, I can copy. I'm going to come over here, and even though these are just values, I'm going to go do paste values just to play it safe. Now we also are going to need a displacement versus time squared graph. So I'm also going to copy my time squared row right there. I'm going to come down here, and I'm going to paste the values. Okay, then notice I'm okay, that was weird. And then once again, I can do a copy and paste of the distance here. Once we have this data here, I can highlight these two values. I can go to Insert. I can select Chart, and I want the scatter chart right here with the dots. Okay, there we are. now that I've done this, I want to format this chart so it's presentable. Namely, I want to create a title like displacement. Okay. I want an x-axis title. I can do that by hitting add chart element, axis titles, primary horizontal, and that will be time in seconds. And then over here, I can, once again, axis titles, primary vertical, displacement, and meters. Okay, so I have my titles. Now there's a few other things that I can do, and to do those, I might want to go over and hit Format, or Chart Design. That's what I want. And essentially, what I want to do is I want to mess with the axes because I don't want so much range here. So what I can do is hit right click, format axis. Okay. And what I might want to do is change by bounds so that instead of starting at 0, we're starting at maybe 0.5. So I'm going to make the minimum 0.5, the maximum 1.5. I like that better. Might want to change grid lines to 0.1 and maybe 0.05. These are some of the fun-filled things that you can do. Okay, and now that I have this, I am pretty much done. Now, what was I hoping to see here? I was kind of hoping to see a quadratic curve, but the thing is that the change in distance was so small. This is probably the best that we can get. Now that I have this graph, I can go ahead and click it over here. I can copy it. I can come over here and to my lab report, and then I can paste it. And there you go. There's my graph. And then I can get rid of these extra line feeds. Now we're going to do the exact same thing for this set of data right here. Now remember, this right here is not time, but time squared. And this is still distance. There we go. So I can highlight these. And I'm going to do the exact same thing I did before. Insert, charts, scatter plot with the dots. There it is. And as you can see, that bad boy is linear. That's what we're hoping for. Okay, so now for this one, a title I'm probably going to use is displacement squared. Okay, that's pretty much what it is. Now, once again, add chart element, axis titles, primary horizontal. Now, this is going to be t squared with units of second squared. Okay. Sounds like a good title for me, or a good title for the axis. And then for the y-axis, primary vertical, that's just going to be displacement. Displacement in meters. Okay, and then there's a third thing that we can do, and that is we can come to add chart element. We can come down to trend line, and we can hit more trend line options. And it brings up this. Now, we want a linear trend line. There it is. Okay. And we want to display the equation on the chart. And there's our equation. And we can actually, if you wanted to, we could actually make that a little bigger. Easier to read. But notice that this slope right here is the same as that slope right there. And the intercept are also the same. So this is also another way you can do regression, and also sometimes it's helpful to actually have the regression line, which is there. You can't see it because the data fits pretty well on this particular graph. And now this here is all finished, and we can go and copy this graph, come over to here, paste it. There it is. And there you go. We are good to go. So you basically have now all of the data in Excel. You can transfer them over to here, hopefully more neatly than what I did, and you can then you can basically copy and paste your graphs over just like this. That's all you need to do, and of course answer these fun-filled questions. And
That is all that I have for this video. If you have any questions, please feel free to contact me. This is Bob Oil, signing off.